Okay, we are live. Welcome to Groundwater Talk Live, where today we are going to be talking about drilling methods for water wells. I know that when small water utilities, especially that I work with, tend to put out a contract for a new well, they decide they need a new well and they are writing the specs to bid it out, that it becomes challenging sometimes to understand what drilling methods are. So our talk today is really designed towards uh, small water utilities and understanding what drilling methods are available to them and what's appropriate for their particular conditions. And that can be a confusing subject. So our guest today is going to talk about that. But first, before we get going, if you like what you hear here, if you like what you hear on Groundwater Talk Live, I appreciate any likes, comments, and shares. I answer all comments, whether it's on the YouTube video, whether it's on LinkedIn or what, the other places we stream. It all helps us beat the algorithm, as it were, and get the word out there. So if you like what you're seeing here, then go ahead and do those likes, comments, and shares, and we appreciate it. All right, so our guest today is going to be John Schwartz from USA Bluebook. He is the technical training manager there, and I met John originally when he was at California Rural Water Association. So we've known each other for a number of years, and he does a lot of training for USA Bluebook, and he's all over the country. So I appreciate John coming on. So let me just kind of bring him in here. Uh, there we go. Pop John on. Hey John, how you doing today?
I'm doing very good. Yourself?
I'm doing well too. So tell us a little bit about yourself and what you do at USA Blue Book, and we'll take it from there.
All right. Well, I've got over 40 years of water, wastewater experience. My water career started when I was in the Navy, stationed in Charleston, South Carolina, and I worked closely with the water and wastewater plants on that base at the time. And from there, when I got out of the Navy, I came across an opportunity for the city of Riverside in Southern California looking for a pump operator, not realizing it was really a distribution operator position. I learned a lot about working on centrifugal and positive displacement pumps in the military and figured I could be a good shoe-in fit for that job as it was advertised. And lo and behold, we ended up being a good fit for 21 years at the city of Riverside. From there, I took an opportunity. I vacationed a lot in Montana and came across an opportunity to take a superintendent's position for the city of Helena. I did that. I did that for 9 years. I would have still been there, but we had a death in the family, and I moved back to California to be close to my father-in-law before his passing. And in that time, when I went back to California, I went to work for CH2M Hill as a startup engineer. And my job as built new water treatment plants, that I would learn the systems, and that I hired staff. I would train the staff on the systems of the plant, so operation, and help them develop SOPs and that kind of stuff. And from there, I did that for two significant membrane plants. One in for the city of San Diego Water Authority. That's the Twin Oaks Valley Water Treatment Plant. It's currently, and at the time was, the largest submerged membrane facility. And we used ozone and chloramination. And then I did another startup after that for the city of Stockton, and so I relocated from Southern California up to Northern California for the city of Stockton, and did the same thing. It wasn't quite as large as a plant. It was only 30 million gallons a day versus the 140 million gallon a day for the submerged membrane in San Diego. But it then led me to an opportunity for the same company to go to Glendale, Arizona. And I had gotten an aversion to high heat, and it's warm enough in California, but 120-degree days just outside of Phoenix didn't sound appealing to me. That's when I first got to meet Tom, as I went to work for California Rural Water Association as a circuit rider and technical advisor, and had a good career there until a gentleman by the name of Don Van Veldhuizen said, "Hey, you do a pretty good job of training. Would you be interested to come to work for USA Bluebook?" And lo and behold, I've been with Bluebook now, going on my coming up on 8 years next February, and it's been a great opportunity to travel the United States, share the knowledge I've gained over those 40 plus years, and met good people like Thomas along the way. So that's kind of my background. So I've done water, wastewater distribution, treatment, membrane, conventional treatment, and managed to pick up a little bit of knowledge along the way.
And you do a lot of training too, so that's good. You know, a lot of people don't realize that USA Blue Book also does training, but you guys kind of do it all. I mean, you got a pretty big catalog, and I know you're at all the major water shows and all that stuff too. And you guys are really plugged in and have a lot of knowledge on especially the instrumentation and all the equipment that's used in the industry. So I appreciate you coming on today, and you're going to talk to us about drilling methods. This is one of the presentations you do, and we're going to have a little bit of a discussion here because, like I mentioned earlier, when a lot of these small and I primarily work with small water utilities, and there ends up being a lot of confusion. You know, us geologists and engineers know all the different drilling methods, but water system managers may or may not, especially when you get to smaller water systems. They just, it's kind of foreign language to them when you start talking about the different drilling methods. It's just like, just tell me what to do. But it's important to understand because you don't want to throw your money away, especially these smaller systems that are, capital strapped. And these days, who isn't capital strapped? But you want to make sure you get the right method down. And I've had some experience with some different projects, and you and I talked yesterday about this a little bit, where we had a project in Northern California, and it would have benefited from a different drilling method. Let's just say we spent over a year drilling two less than 100-foot wells, and in some difficult, cobbly rock, well, it was alluvium basically, very cobbly, and they would have benefited from some different drilling methods, but the engineer on the job just was reluctant to change things out, and thus we spent a year drilling two shallow wells, and it was just over a year actually. It was ridiculous. So it really does matter. The drilling method you select really does matter, and geology counts when it comes to these things. So you got to match up the drilling method with the geology and choose the appropriate one, or you may be getting a lot of change orders and throwing a lot of money away. So let's kind of move on. And you got a presentation to share. So let me do this here. And oops, we don't want to do that. Uh, yeah, let's get rid of that. There we go. So uh, so go ahead, John, and
All right. Well, first, I want to thank our audience for joining us today, and Tom for having me join the Groundwater Talk show. I appreciate that. We've been trying to do this for quite some time, and my schedule and his just kind of lined up, and we got to do this, and hopefully we can do some more in the future. So if you like today's presentation, as Tom mentioned earlier, please like, share, and comment. And we're going to get going with water well drilling. So here's just a picture of a crust well, and just overflow. We sometimes refer to these infiltration galleries, and generally they are artesian type wells. So we're going to talk about the types of wells. So we have a dug well, driven well, and drilled wells, and that's where most of our focus is going to go. But I didn't want to just leave out the other types of dug and driven wells. So dug wells are generally holes in the ground dug by a shovel or a backhoe, generally typically 10 to 30 feet deep in very high groundwater situations. Historically, a dug well is exactly below the ground level table, and until oncoming waters exceeded the digger's bailing rate, the well is then lined and cased with stones, brick, tile, or other material to prevent that dug hole from collapsing.
And John, just as a disembodied voice from the background here, yeah, there you go. I'm here in Tennessee. We still have a lot of residential properties out here that are on old dug wells. And the challenge with dug wells is they take shallow water and surface water, and you tend to have a high risk for coliform, especially when they're somewhere near their septic system. So
Oh
we
yeah,
don't
that's something that's
for
very
water
important.
districts we don't really see, yeah, dug wells.
No, not in a small district. Residential, very common. In fact, my first experience when I was in high school, a friend of the family, we lived in New Jersey at the time, and very sandy soil, much like you see this horse is the old adage, you can't take a horse to water and make them drink, but if they're thirsty, they'll find water. And so it was so sandy soil like this that I helped do my first driven well. We set up an A-frame and a weighted pipe and just slowly chugged away at driving that down into the ground and doing that. And again, like we said, Tom mentioned about being important where that well is located when you do a dug or driven well. Keep it away from your septic system. Rule of thumb is greater than 250 feet uh, for the soil to clean that water up. Uh, and again, you have a hillside or something like that. You want that well to be higher elevation than that septic field and where that water is going to flow downhill through the soil. So, driven wells. We're going to pull water from a water saturated zone above the bedrock, typically 30 to 50 feet deep, and located in areas with thick sand and gravel deposits where the groundwater table is within 15 feet of the ground surface. The other thing that's important when you do a driven or a dug well, that you get down into that water table, not just the saturated zone where you're going to not have a continuous flow of water. In the dug section, we talked about making sure we get above that bailer's rate. You got a bucket or whatever system you're using. You want to make sure you got a good, strong supply of water when you do a driven or a dug well. So the proper geologic setting, driven wells can be easy and relatively inexpensive to install and relatively shallow and have moderate to high risk of contamination from nearby land activities. So it's very important, again, where you place this well. And here's an example of a driven well, or you can see the sand point, the casing, the well screen, where the water level is. And just another example of that. And it very common, these old wells, when they were first put in before we had electricity to some of these, it just was a hand pump.
Yeah, and these are going to be pretty shallow wells if you're driving them. You got to drive them down, and the point has to stay open, and generally going to be in alluvium. Probably not going to do go too deep with a driven well in rock unless it's very loose rock. So I was looking at out here in Tennessee where we have some really shallow karst, thinking about maybe just, experimenting around with the drive point and trying to drive it down in some fracture zones and see if I could get get a small well just to play around with it. But generally it's going to be alluvium and pretty shallow in order to do these things. And once again, probably residential type wells.
Yeah, and you're just using the weight of the pipe to kind of drive that into that alluvium soil. We set up an A-frame and we just used the weight of that pipe and just kept raising and lowering it and letting the weight of the pipe fall to drive it in farther and farther into the soil. And it was quite a learning experience as a young man at high school age. And here, many years later, we're still talking about doing wells and stuff like that. So it's been a good career for me. I think it's been a great one for Tom as well. And hopefully, those of you that are participating in today's video, that it's always been a good thing for you. It's always something new every day in our industry. So we're going to talk about drilled wells now. Drilled wells penetrate 100 to 400 feet or much deeper, depending on where you're at. Feet into the bedrock, where you find bedrock at the surface, is commonly called the ledge. And to serve as a water supply, a drilled well must intersect bedrock fractures containing groundwater. Sometimes it may be not bedrock, it may be a clay for a confining layer or an unconfined aquifer. When I first started with the city of Riverside in California, there's a very large aquifer called the Bunker Hill Basin in Southern California. And that's where we got a majority of our water from. And at the time, that aquifer, when it wasn't being pumped, all of those wells were artesian wells located in San Bernardino Valley. And so in the wintertime, uh, our agency benefited from that artesian well flow uh, because we didn't have to run the pumps to get water. We could average about 15,000 gallons a minute artesian flow from those wells that we'd normally pump. Today, due to the droughts in California and water usage, that same area is now pumping from 400 to 500 feet deep. So it's gone from uh, 40 years ago, where it was an artesian area, to now they have to pump that area at quite some depth.
Pretty amazing. And when we talk about artesian, that's where the pressure head of the water table actually is above the ground surface. So the water, the pressure from the groundwater, the pressure head or the head is actually above the ground surface. So the water is free flowing out of the well. So that's probably a good simple explanation of what an artesian flow is. Probably don't get too much of that anymore. I mean, it used to be fairly common, but with all the groundwater pumping and the depletion of aquifers, don't really see artesian flow much anymore um, in most areas. There's still some areas where you can get artesian wells, but it's a lot rarer than it used to be. So that's an interesting story. So and yeah, and I would like to point out too that yeah, we really have two types of situations that we're drilling into. We have the alluvial aquifers, which you get like in the Central Valley of California a lot, and then you have the bedrock aquifers, which you also get in California a lot. And it's kind of a different strategy for each, and we'll talk about more in the different drilling methods. But yeah, so thanks for thanks for that story on that's quite a difference down in Riverside. Over how many years was that we get
Oh yeah, for
that you go
40
from
years,
artesian?
I worked in the early 80s through 2000 to work for that, and uh, even in 2000 when I left City of Riverside, those wells would still recover in the wintertime and still flow artesian. But in the 23 years since then, uh, they have gone from artesian wells to they have to be run and pumped all the time, and they're pumping from a very deep level. So they've kind of really depleted that aquifer. And Tom, you may also make comment about the area in Central California where they had subsidence because of the aquifer's been overpumped and it's actually not been able to recharge because the land has settled into the aquifer.
Right. Yeah. It's yeah. So it yeah, and you get that mainly in areas of alluvial where you have clays and you have alluvium that um so uh, so that is I got a comment here. I'll just pop that up on the screen here. I don't know if you can really read that, but 1 Million Wells says, I'm the winner of the Patents for Humanity Award of the USPTO for my invention of a new method of drilling. We have drilled over 750 wells all over the world. They use airlift reverse flow. So I'm not, I think I have an idea what that is. I'm not totally familiar with the method. So at some point, um, I suspect these are probably stuff that's done, probably I see a lot of these innovative methods out in Africa, and so they're drilling these things by hand, he says. So it's just kind of interesting here. Let me pop this one back up. So not totally familiar with that method. I think I know what it is, but thanks for the comments. Yeah, you get to places like Africa where they have shallow groundwater, but not a lot of technical skill. And some of these innovative drilling methods can be really important. So um, because you just don't have the people there that can run a sophisticated drilling rig like we're going to talk about here. So sorry to interrupt, John,
Oh,
but
not a problem.
had some comments here. Just go ahead. So
Yeah, we enjoy those comments and answering those questions and stuff like that. Uh, Tom and I were talking yesterday that you can learn from these PowerPoint presentations and the knowledge that Tom and myself will share during the presentation. But it's always more important to have those questions and comments, to have that conversation to expand that learning. So we covered types of wells. We're going to talk about drilling now. So here's some pictures of some different types of drilling rigs. So common drilling techniques, cable tool drilling, a cable tool rig. Percussion method of drilling, cable tool, churn and drill, sputter, pounders, and sometimes referred to as the oldest cutting actions utilized in the drilling industry. They were very commonplace when I first entered this industry many years ago. And they've been around for quite some time prior to that. So cable tool drilling is one of those aspects and types of drilling rigs. Then
and
we
this is
have,
yeah, and if we can, go back to the cable tool, a lot of people think that's outdated technology, but there are still cable tool operators out there, and in certain circumstances, like the one I was mentioning earlier, where we had the drilling difficulties, in that situation, we would have been better off coming in with a cable tool, but I got a lot of resistance to do that because the everybody wants the shiny modern stuff, but sometimes something like cable tool might be the best tool for the job. It just depends on what your situation is, what the geology is, and there's a reason that there is still cable tools around. They're still getting work, and sometimes they are the best drilling method for your particular geologic situation. So don't discount it because it's an old method and that it isn't widely used anymore because it may be exactly what you need. So we really like to look at all the techniques that are available and yeah, that most of the time more modern drilling methods are going to be the appropriate tools, but there are situations where cable tool might be just what you need. And I will tell you that the cable tool drilling may take a little longer, but it's going to be less expensive too. So it's and some of those good cable tool operators really know their stuff and they can move right along. So I've used them and like I say, in the right situation, that may be just what you need. So don't discount it because it's an old method is what I'd like to say.
yeah. Well, and then yesterday, Tom mentioned we're talking about some of the topics we were going to talk about. And one of the things we talk about, one of the reasons it's a little bit more cost affordable is the staff required to operate. One or two people can operate a cable tool or drilling rig very quickly, very easily by themselves. Some of these other ones is when you have more people involved. More people means more payroll, more expensive. So then we have rotary and reverse rotary drilling used on unconsolidated or semi-consolidated materials and requires large amounts of circulation water. This is where we kind of first get our introduction into having a recycled water supply. Sometimes they use the natural materials that comes up from that cutter head. Sometimes you'll use a pond or some type of a containment, and they'll add bentonite clay to act as that drilling aid and coolant for the bit. And then we have air rotary drilling. Used on hard rock materials, the air rotary and down the hole hammer drilling system are similar in design and function, with the main difference being that the latter system having the additional cutting action of the air driven hammer. So it uses air to lift and then drop and lift and drop. And then we have a bucket auger drilling system. The bucket auger is used primarily on unconsolidated material for constructing large diameter boreholes ranging from 24 to 48 inches. So I mentioned about when I worked for City of Riverside. City of Riverside is a large community, and it had an average daily flow of about 58 to 60 million gallons a day. And in the summertime, our peak was about 120 million gallons a day. And we had a lot of large wells that had large 24 to 48-inch type casings associated with them because we had such large producing wells. And again, with those large diameter casings, that made it easier for that water than when it was artesian to be able to flow up. And some of these wells that I worked with in City of Riverside that were located in San Bernardino County were producing 4,500 gallons a minute to 5,000, and all depended on the size of the pump and where it was at and the depth. And as water quality became more important, we started having to go deeper and deeper into these aquifers to get better quality water.
And John, also, I would say that the bucket auger drilling tends to be limited by depth. There are depth constraints on that. So typically, bucket auger drilling is going to be used a lot in for construction testing, but where we use it in water wells, I see it if you have a large conductor casing that you're putting in. Sometimes bucket auger, they'll bring in a bucket auger to put in a large diameter conductor casing if they need to, and cement that into place, and then come back in with another drilling method to actually complete the well to greater depth. So the bucket auger will be a little more efficient in drilling these larger diameters. If you're putting in, say you got to put in 50 feet of conductor casing that's going to be, like you say, 24 to 48 inches. A bucket auger is going to be the most efficient method to do that, and then come back in with your regular drill rig to actually drill the actual well. So just
Yep.
wanted to point that out.
Yeah. Very good. Thank you, Tom. And then we have some other common techniques is down the hole well drilling. The difference between air rotary and this drilling system are primarily the cutting action and the resulting cuttings. The down the hole hammer uses the rotary percussion cutting action through the use of a button bit. So, Tom, would you be able to tell us the difference between a button bit and a standard rotary button, a rotary cutting head?
Yeah, generally, and I don't have a picture I can throw up there, but generally, the button bit is going to have carbide buttons that are little round buttons that actually very hard and they cut. Usually for rotary, they're using a tricone bit that actually three cones that actually rotate, and they can go from buttons to actual sharp teeth. So there's when it comes to drill bits, my goodness, you go to these different drilling shows, and there are all varieties of different drilling bits. But when we're talking about down the hole, you're calling it down, I call it downhole hammer.
Mhm.
They're using a button bit that's driven by air that's basically like a little jackhammer. It's pounding up and down and pulverizing the rock is generally how that works. So it's all driven by air, and that can either be reverse circulation or straight drilling. Most downhole hammers now, I think, use reverse circulation, but there's still some that don't. But the air blows everything, all the cuttings out. So to clean the hole in front of the bit. But yeah, that's kind of the difference. And boy, we could do a whole show just talking about different bits. You
Yeah,
know,
different
I
cutting
mean,
heads. Yeah, yeah.
yeah, it is.
Well,
There is quite a variety out there. I mean,
oh yeah.
yeah,
Well, and then I was always amazed when I was first introduced into well drilling and stuff like that, is that they say, well, you're cutting that in and you slide in the casing in behind it, and I'm like, how does this work? Do we just leave the cutting head down there when it's done drilling to the depth? Because how do you get it back out? I didn't realize that when the cutting is head, the head expands on those two or three different size cutting wheels. And then when it stops and they reverse it, they retract. So that's how what allows it to come back up through the casing pipe. It's one of those weird, wonderful things you don't stop and think about it until like, how are they going to get that out of there? So then we have reverse circulation drilling method. Reverse circulation drilling system is quite unlike any other system profiled in that it's a very large rig requiring a big footprint for both the rig itself as well as the machine and a dug pit, settling pit. So here's the example that I mentioned earlier. We can have a pit that we send our recycled drilling material through our drilling mud, or we can use some type of one of the ones that I'm most familiar with. It's just a large Connex box, basically, and they were used to be supplied by a company called Rain for Rent, and I'm sure there's many others. And you would just run your drilling mud through that instead of digging a big pit. But both are acceptable.
yeah, and yeah, reverse circulation. You know, we see a lot more of those out there these days, and really what it does is it's a dual wall pipe. So your cuttings, instead of coming up on reverse circulation, your cuttings, instead of coming up the outside of the pipe all the way to the surface, actually get pulled into an interchange above the drilling bit, and they pull it up inside the in that inner tube and bring them to the surface that way. So it's a little bit more efficient system, but it's also more expensive to drill with reverse circulation, and because the drilling pipes, obviously because they're dual wall, are much more expensive. So you're going to find that reverse circulation is going to be a little bit more expensive technique just because of the equipment involved, and you have to have, you know, pretty good circulation with, you know, to push things up the inside of the up the inside of that inner pipe. So that's important to note here on reverse circ drilling. So,
Thanks, Tom. So we're coming up to the last one that I have information on is mud rotary drilling. The mud rotary drilling method is considered to be closed loop system. That is that the mud is cleaned of its cuttings and then recirculated back down the borehole. So that's kind of mud rotary. That's very similar to what Tom was talking about, the reverse, where you have two pipes and one's going up, one's coming back down. Then now Tom is going to talk a little bit about flooded rotary drilling and sonic drilling.
yeah, let me just talk about, yeah, the flooded rotary. I am not as familiar with, but it's basically, I haven't used it a whole lot, but it is out there. It's a newer method. I guess you could say that if anything is newer in the drilling industry. But the flooded rotary really involves continuous circulation of a drilling fluid. And I'm sorry, I probably should have popped myself back up on the screen here, but so I'm kind of a disembodied voice. But continuous circulation of a drilling fluid, usually going to be water or mud, while while running the drill bit at the bottom of the borehole. Um, the drilling fluid serves multiple purposes. Obviously, it's removing cuttings from the hole, stabilizing the borehole, cooling the drill bit, and so it's um, basically so it's usually a mud or some kind of fluid type drilling. So it's not done obviously with air. Um, and so basically the mud is carrying things to the surface, the cuttings to the surface. So it's a variation basically on mud drilling. Now, sonic drilling, that's kind of it in a nutshell. Sonic drilling is probably one of the newer methods out there, although it also has been around for a while, but is constantly being more perfected. It's going to be one of your more expensive drilling methods, but it's an interesting method, and in the appropriate situation, sonic can be a good tool. But it basically, in a nutshell, sonic drilling uses a combination of high frequency mechanical vibrations and rotational force. So some combination. You're basically that's where the word sonic comes from. Is you're using the high frequency vibrations to basically uh, break and cut the rock in these small areas around the drill bit. So the high frequency resonant energy that's produced by the sonic head is transferred down the drill string to the drill bit. And so it causes a rapid rotation of the drill bit, which serves to reduce the friction between the soil or the rock and the drill bit, allowing it to penetrate the ground easily. Now, I have used sonic drilling mainly in back when I was doing environmental work, and it does have some limitations, especially if you're in harder rock. It's a lot slower method. Um, but in the right conditions, it can actually go faster than conventional methods, especially where you have very geology. So it obviously produces less drill cuttings, which minimizes waste and disposal costs. And always it's a matter of what do we do with the drill cuttings. And what you're getting is, and this is as a geologist, I love this is you're getting basically a core coming out, and so you're able to log the hole in a lot greater detail. So if that's important to you, and if you're looking at zeroing in on particular geologies, then say you're in an area where you have known contaminants, you have arsenic zones, some lithologies that have high arsenic, then then this can be a great method for nailing down those zones and developing a well that's going to screen or seal off those particular zones. Less drilling fluid involved, so less muss with that. So um, and so that is basically I really like it because you can really nail down where your well screens are going to go with sonic drilling. There's no doubt, absolutely, because you're pulling that core out and you can accurately place your drilling screens. I've seen some wells drilled with other methods where it's kind of by guess and by gully. So sonic is really a good method that allows you. But I will tell you, it's going to be quite a bit more expensive than just doing straight mud rotary drilling. So, so you really need to, in my opinion, and the sonic drillers out there may argue with me, but in my opinion, it really depends on the geology and your specific application if sonic is going to be the appropriate method for you. So that's sonic drilling in a nutshell. It's like I say, substantially different from some of these other drilling methods we're talking about, and so that's important too. So John, back to
So,
you.
yeah, well, thank you, Tom. And so just kind of to wrap things up here a little bit, as if you're going into a project to get a new well for your community, that talk to the existing well drillers in your area. Talk to a geologist, a hydrologist, and they will give you information about the soil conditions, what's there, where you might be expected to find water at what levels in different areas. And because that's very important, because when you hire a company to drill a well, they're just putting a hole in the ground, whether it's a wet hole or a dry hole is really happenstance, but you got to pay for that dry hole just as much as you would pay for one that was getting water. So it's very important that you get as much information when you're going to do a new project for a new well. Again, like Tom had mentioned about the sonic drilling, it gets you cores. You can find out where arsenic levels are, nitrate, any other things that you want to be concerned with. Because one of the things is if you just go and drill that well and say, okay, well, we're going to put screens in at this level and then again at this level, well, you might be bringing in some water from a highly arsenic area. Or if it's a shallow well, you might get some nitrate issues. So it's important to do that and get that knowledge. You can get that water from water records, uh, depending on the state. A lot of states have requirements for well measurements and other data logs for when the wells are drilled to sit there and get ideas for your geological area and circumstances. So look into that. Just don't rely on contracting that out with if you have a engineering firm that you contract with, or if you have onboard staff that's our engineers and doing these projects, give them all the information they can to get a better job done as the project does everything moving forward. So here's
So,
my contact information and
w-
stuff with USA
w-
Bluebook. And Tom, you started to say something. Please continue.
yeah. Okay, yeah. Hold on just a minute. I got a comment here that popped up, and it's kind of hard to read it, so I'll just read it. So, 1 million wells says drilling mud can destroy the aquifer. The mud must be removed from the walls of the borehole at the aquifer. And yeah, this is something that I've talked about in past shows. Is well developed. If you're drilling with mud, the mud invasion into the formation, and this is a very good point, can be problematic. And I would say that one of the biggest problems I see with new wells is lack of adequate development to get the drilling mud out. So very good comment here, and that is kind of one of the downside. I mean, drilling with mud helps stabilize the borehole walls, and there's a lot of advantages to it. But the big disadvantage is you get mud invasion into the formations. And as a consequence, you're going to have to spend a significant amount of time uh, doing development to clean that mud back out. So you put the mud in, now you're trying to take the mud out. And inadequate development, like I say, is a huge problem out there. I see uh, there are some common problems that I see that crop up with different wells, and inadequate development is right up there on the priority list because they're not taking the time they need to get all the mud out. So it's using some different methods, and maybe I need to get 1 million wells on the show here to talk about his drilling methods, but it's there are pros and cons to different things. I mean, air is certainly, a little cleaner, but it has its challenges too. It's better in rock formations. Mud works, and um, so uh, so that's it. So 1 million wells says that airlift reverse circulation does not require drilling mud. So that might be an advantage too, where he drills. I'll have to talk to him more. So hopefully I can get in touch with him and get some information. But so I just wanted to throw that in there that's a whole other topic is well development and different drilling methods. Um, and the well construction, well performance. So probably another topic for another show because we're kind of running long here as it is. So go ahead, John. Tell us about USA Bluebook, what you guys do, and let me move you over here so we can read your contact information.
So thank you for that, Tom. At USA Bluebook, maybe most people in the water industry are familiar with us. We publish a catalog almost every year. We've kind of changed that up a little bit with supply chain shortages and the pandemic and stuff. But we do have a new catalog coming out. It should be most of you that are customers should have received it already this month. And we're very proud to have that new catalog out again. And then also, we're an MRO company for those that aren't familiar with it, maintenance, operation, and repair. So we offer anything from chemicals to pumps, chemical feed pumps, repair equipment for pipeline uh, leaks, that type of stuff. Uh, we're right now in this being very supportive of the new lead and copper rule. So we're advertising a lot of stuff associated with that. And but yeah, we do anything from safety equipment to workwear to knowledge. We share. We have a lot of books that we share, and as Tom mentioned, that we are a training company as well. Uh, right now, there's two trainers, myself and Betty Green. She focuses on the wastewater side of stuff, and so we cover all aspects of water, wastewater treatment, collections, and we're quite proud to do that. Uh, I enjoy working for USA Bluebook. I love their tagline, "Get the best treatment." Uh, we really do believe in great customer service and stuff like that. And again, myself as a trainer for USA Bluebook, there's my contact information. Always open to getting emails or a phone call. If you
Pop
happen
that.
to give me
Oh,
a
I'm sorry.
call, no, not a problem. If you happen
Yeah,
to
I lost it.
give me a call. I don't answer. I'm probably teaching a class. So best way I always recommend, send me an email in the evenings or after a class. I always go through, check my emails, and always happy to hear from people. Uh, if they have questions on a training I've done or give me just general information, that's one of the nice things of 40 years in this industry, working from starting as a construction maintenance worker to a pump operator, distribution operator, treatment operator, and up through management. So I've learned a few things in my day, and the nice thing is I'm open-minded, so I'm always learning new stuff as well. I think that's what makes me a good trainer is that I've always got an open mind. I haven't stopped learning myself, and as I learn new stuff, I share it. So again, I want to say thank you for those who that attended our presentation today. Tom, thanks for the invite. We hope to do this again.
Thanks, John. And I will. I'll put your contact information also in the YouTube video notes and on LinkedIn too, so that people can get in touch with you. And you know, if you haven't heard of USA Bluebook, why not? You know, I mean, it's yeah, they're out there and they have a complete catalog. I can tell you. So. So John, thank you very much. I appreciate your time and have a great day. And we'll do this again sometime.
Most definitely. Thank you again for the invite and glad we can work our schedules to do this. So
All right.
again, thank you. And thank you for those that participated in today's class training
Okay.
stuff. Thank you.
Bye now. All right. Many thanks to John for coming on the show and USA Bluebook is a great resource. They answer questions and they have so much equipment and they can answer questions and all that stuff. So that's good. So thank you very much for coming here and all the comments. 1 million wells. I appreciate your comments. I don't think I got them all up on the screen, but that was some pretty awesome stuff. I read them and I really appreciate that. And so that is our show today. And if you want to be a guest on a future show, you can sign up at this URL. That is our URL for getting on the show as a guest. And if you're a groundwater expert, I would love to have you on. So just go here, sign yourself up, and we'll get you scheduled on the show. So thank you very much for attending today. Don't forget to subscribe to the Groundwater Guy YouTube channel. We do this every Thursday at 11 a.m. Central. So I appreciate everyone that came on here and made the comments and